We begin Mod 9A by solving logarithmic equations. In order to solve logarithmic equations, the first thing you are going to do is isolate the logarithm. Get the term with the logarithm by itself. Then you use the definition of a logarithm to write in exponential form instead of logarithmic form. Once you've done this, you've solved for the variable. We are going to solve some simple logarithmic equations for the variable. When you are solving a logarithmic equation, it is important to remember that you must check your answer. Our first example is log base x of 27 equals 3. The logarithm is already isolated. It's the only thing on the left side. So we're going to go straight to writing in exponential form. In order to do that, we would have x to the third equals 27. Well, what number to the third equals 27? That is 3. For the check, it would be log base 3 of 27 equals 3. Do the rewrite, you would get 3 to the third equals 27. Is this true? Yes. On our next example, we have log base 7 of x equals -2. The logarithm is already isolated, so we're going to go straight to writing in exponential form. Exponential form would give us 7 to the -2 equals x. Well, to make that positive, we would write it as 1 over 7 to the +2. This gives us 1 over 49. If we put that into our original equation, does that give us a true statement? Yes, it does. We're moving on to slightly more complicated problems, and on this problem, we have log base 3 of the quantity -4x plus 10 equals 4. The logarithm is already isolated, so we can go straight into exponential form. Exponential form would give us 3 to the fourth equals -4x plus 10. 3 to the fourth is 81. So now we have a simple algebraic equation to solve. We're going to subtract 10 on both sides, and we will get 71 equals -4x. Divide by -4, we get x equals -71 over 4. Now let's check our answer. We have log base 3. In our quantity, we have -4 times our answer that we got of -71 over 4 plus 10, close your quantity, equals 4. Well, first of all, the negative times the negative is going to give us a positive, and the 4 in the top, 4 in the bottom gives us 1. So we now have log base 3 of 71 plus 10 equals 4. So we have log base 3 of 81 equals 4. If we rewrite that in exponential form, we get 3 to the fourth equals 81. Does our answer check? Yes. On our next problem, we have 4 times log base 2 of the quantity x plus 12 equals 12. Notice that our logarithm has a times 4 on the front of it. It is not isolated. So the first thing we're going to do is divide by 4 on both sides. Now we will have log base 2 of our quantity, x plus 12, equals, on the right side, 12 divided by 4 is 3. Since the logarithm is now isolated, we go to exponential form. 2 to the third equals x plus 12. 2 to the third equals 8, equals x plus 12. Subtract 12 on both sides. You get x equals negative 4. You are not done until you do your check. Putting negative 4 into our equation, we'd have 4 times log base 2 of the quantity, negative 4 plus 12, equals 12. We still have to divide by 4 on both sides. We get log base 2. Negative 4 plus 12 in our quantity gives us 8, equals 3. Go to exponential form. 2 to the third equals 8. Is that a true statement? Yes. So our answer checks. Here we have negative 7 times log base 5 of 4x equals negative 14. Again, we have our logarithm being multiplied by something on the front, so we're going to divide both sides by negative 7. Now our equation becomes log base 5 of 4x equals 2. Since our logarithm is now isolated, we go to exponential form, which would give us 5 to the second equals 4x. 5 squared is 25 equals 4x. Divide both sides by 4. We get x equals 25 over 4. Now for our check. We would have negative 7 times log base 5 of 4 times our answer, 25 over 4, equals negative 14. Divide both sides by the negative 7. We get log base 5. 4 times 25 over 4, the 4 over 4 equals 1, and we get 25 equals 2. Go to exponential form, you get 5 squared equals 25. Is that a true statement? Yes. So our answer checks. On these problems, we are still solving for the variable, but these problems are going to involve natural logs instead of logs of other bases that we might get whole number answers. Because they are natural logs, we're going to get answers that we have to round, and our directions tell us to round to the 100th. The first problem we're going to look at is 5 plus the natural log of the quantity x minus 2 equals 2. The first thing that we're going to do is subtract 5 to get the natural log by itself. This now gives us the natural log of the quantity x minus 2 equals negative 3. Now that our logarithm is isolated, we want to go to exponential form. In order to do that, you need to remember that the base of a natural log is e. So exponential form of this equation becomes e to the negative 3 equals x minus 2. We're going to add 2 to both sides, and we have x equals e to the negative 3 power plus a 2. Now doing this on your calculator and rounding to the second decimal place, you should be getting an x of approximately 2.05. We still need to do a check. I'm going to use this version of our equation to do my check. I would get the natural log of 2.05 minus 2 equals -3. This would give us the natural log of 0.05 equals -3. If you do that on your calculator, you will find that that is correct. On this example, we have the natural log of 5 plus the natural log of the quantity x minus 1 equals -1. The first step on this problem is to recognize that we have two logarithms that are the same logarithm, type of logarithm, and they are being added. And that means using our properties of logarithms, we can convert that to multiplication of a single logarithm. So it becomes the natural log of 5 times x minus 1 equals -1. Distribute the 5, so now we have the natural log of 5x minus 5 equals -1. Since our logarithm is isolated, we go to exponential form, which gives us e to the -1 equals 5x minus 5. We're going to start by adding 5 on both sides and get e to the -1 plus 5 equals 5x. Divide both sides by 5, and we now have x equals e to the -1 plus 5 divided by 5. Put that into your calculator and you get an answer of 1.07 rounded to the 100th place. To do the check, go back to the original and you would have the natural log of 5 plus the natural log of 1.07 minus 1 equals -1. This becomes the natural log of 5 plus the natural log of 0.07 equals -1. If you do that on your calculator, you will find that this is correct.